Okay, hi class. Today we're going to be discussing dilutions of solutions. This is chapter 9.5. We're almost done. Chapter 9.6 is next, and we're done with this chapter. Dilution of solutions. The best way to describe it is if you've ever used these concentrated frozen orange juices, or think of concentrated punch that's really syrupy, and then you add water to it to dilute how, sickly, it's kind of too sweet. You would not want it, drink it just straight from the bottle. So what you do here is you take that 1 can of frozen orange juice concentrate, and then you use 3 cans of water using the same can. That equals 4 cans of orange juice, and you stir it. So what you did is you started with a really concentrated orange juice, and then you diluted it using just by adding water to it. And now it's what, you would normally drink as orange juice. This is a dilution. So a dilution, water is added. The volume of the solution increases, concentration decreases, but the mass of the solute in the solution remains the same. What does that mean? So the first thing is, if we look here, we start with a specific amount, which was whatever was equal in here. And if there was mass on here, and I'm sure there is, it means it was weighed out. That amount was weighed out. So they know, let's say it's maybe 5 grams of orange juice. The 5 grams does not change through this whole thing, even though it's been diluted. It's because we're not interested in the mass. The mass was what was actually used to weigh out this amount. But we're changing the volume, not the mass of it, even though we decrease, it's decreasing the concentration, increasing the volume. So water is added, the volume of the solution increases, and that's exactly what happens here. We take the concentrate and water's added, and it's now diluted. The concentration decreases, but the mass of the solute remains the same. So now we're going to use a formula to determine diluted solutions, or we start with diluted and we work backwards. This is C1V1 equals C2V2, or you will see this in some books as M1V1, M2V2. And what this means is the ones are the initial conditions, and the 2 is the diluted conditions or the final conditions. It's one or the other. So initial and final is the easier way to state this over diluted. And what you will be given is 3 variables, and you'll have to solve for the 4th. So if you ever get a problem and you're confused, if you see that this is 3 variables, chances are it's a dilution problem. Excuse me. So C stands for concentrate, and V is volume on these. So this is initial concentrate, volume, initial volume, final volume, and final concentration. So when water is added to a concentrated solution, there's no change in the number of particles. So if we start out with a certain concentration, going back to the orange juice, we started with a certain amount of particles. Even though we added water, the particles never left. They are still there. They're just able to swim in more water volume. So the particles don't go anywhere. They are closer together here because this is more concentrated. However, when we add water to it, now they have more space to move around. And by adding volume to this. So what is the final concentration when 0.50 liters of 6.0 molar HCl solution is diluted to a final volume of 1.0 liters? And you should also predict what's going to happen, because that'll help you determine if your answer's right or wrong. So we're going to make C1 as 6 molar. The initial volume is 0.50, and the final volume increases to 1.0. So because it increases, as the volume increases, that means that the concentration has to decrease. So that's what we suspect will happen with this. So we believe that the new concentration will be lower than this because it's diluted. So solve for C2, which you solve here. Now plug everything in. We have our C1 as the 6.0 molar. We have V1 as the 0.50 liter, our initial volume, and then our final volume, and that gives us a 3.01 molar HCl. And that makes sense because we started with 6, and we actually increased the volume. As you can see here, 0.50 is half of 1.0, and that leaves us with the 3.0 molar HCl. So we diluted, increased the volume, and now we have a not as strong molarity. What volume of a 2% HCl solution can be prepared by diluting 25.0 mils of a 14% HCl solution? So this sounds like a very difficult problem, but you're given three variables here, and three variables will allow you to solve for the last variable. So we're given C1, 14%, V1 is 25 mils, C2 is 2%. We need the volume on this one. So if we look here, the concentration is decreasing, so we expect the volume to increase. And so we solve for that, and this leaves us 175 mils solution. So we expect the concentration decreases, volume increases. So we went from 25 mils to 175 mils, and that's exactly what happened here. By the way, it also can go the other way. That's why I don't like saying diluted, because you can be given this information, these three variables, and you can solve for the original, the initial concentration or the initial volume. So it can go either way. What is the percent of a solution prepared by diluting 10 mils of a 9% sodium hydroxide to 60 mils? So again, let's break down what we have. We're given C1, which is 9%. Our initial volume is 10 mils, and our final volume is 60. They messed up. They put a percent there. 60 mils. So we are trying to find what the concentration is. So what do we expect to happen? Well, the volume increases, so that means the concentration must decrease. And so we set up for the final concentration, and it ends up producing a 1.50% solution, and that has decreased, and that's exactly what we expected with the volume increasing. What is the molarity of a solution prepared by diluting 0.180 liters of 0.600 molar nitric acid to 0.540 liters? Again, it sounds very difficult. It sounds overwhelming. Don't panic. Pull out. Start writing out C1, V1. And if you have three variables, then chances are, the key word here too, it's also saying diluting. It's a dilution problem. Not difficult at all. Set it up correctly and solve for the variable that you need, and you should be fine. So if we set everything up here, we're solving for the new concentration. The new concentration ends up being 0.200 molar from 0.600 molar. So this tells me that the concentration went down, so the volume must have increased. And that's it. Thank you.